Ladies and gentlemen, welcome back after the break, and we are following by the project of the data quality for the Generali insurance company. Floor is yours.
Well, hello everyone. That isn't start of our presentation, I'm sorry. Okay, thank you. Before we start, we set up our presentation, right? And I just wanted to ask you, have you ever struggled with data quality? Yeah, you did? Yeah, nice. Generally did too, until recently, until our help. Just before we start, I just want to mention that we are obliged to say that data quality in general isn't exactly like this, and we were performing these results on testing data for the sake of our presentation. Right now, I will tell you something about the current situation. In general, I want you to meet Jimmy. Jimmy is a happy worker in the actuarial department, and Jimmy usually once per month receives large number of databases directly from the data warehouse, and with these databases, he is performing some insurance calculations, or he creates some reports. And these reports often contain some mistakes, and these calculations contain some mistakes too. And since Jimmy is a smart guy and he hasn't made these mistakes, he knows that these mistakes must come from the databases, or what is even worse, from the data warehouse itself. And right now, Jimmy has his reports with errors, and he has to trace these errors back and trace these errors even from the calculations all the way back to the databases. And he has to repeat his whole work for many days, and he has to perform these calculations and create these reports all over again. And Jimmy is confused, and Jimmy is sad because he's working and his work is delayed. And how can we help Jimmy? We can go into data warehouse itself and clean the data there. But since we are working only for Jimmy and his actuarial department, we are not allowed to touch the data in the data warehouse itself. So we had to come up with another solution, and that solution will be a Python application that will compare three things. Firstly, the new databases. Secondly, the older databases. And finally, the list of given benchmarks. These benchmarks were given by Jimmy himself. And these benchmarks tell us how much can these values change between two periods of time. And after we give these inconsistencies or these possible errors to Jimmy, he can go and find the errors easily and faster and correct them into databases. So he can go and work on the calculations and the reports just once, without any delays and errors. So what is our value proposition? We will put an end to the manual and retrospective error tracing, which will save a lot of time. Actually, several man days monthly, at least. And this saved time can then Jimmy and his co-workers use for creating more accurate and more precise reports and deliver them faster. And by delivering the reports faster and more accurate, his boss and his management will surely be happy, and Jimmy and his co-workers will have increased reputation.
As for the technical flow, the user of our application needs to upload 4 files. First, a list with allowed value for each variable, list with paired variable to the responsible colleague, current database, and database with already clear data from previous term. After that, our application finds any errors and inconsistencies. Next step, user can review the results, download them, or send them directly to the responsible gestors. Lastly, the results with data are sending to the Power BI dashboards. Here is interface of our application. On the left side, you can see window for uploading files, 2 lists and 2 databases. On the right side, there are panels with blue ticks which are representing actual progress of the current run. This is how it looks when our application finds errors. Yellow columns represent error type 1. They are least severe. They miss the given limit just slightly. Orange ones miss the limits by 3 times. Red ones, third, they miss the given value by 5 times. Up above on your menu, you can see filters. You can filter variables by databases, tables, and dimensions. Also, you can filter variables by responsibilities. And after this, you can send a report to the right person who are responsible for each variable. We are able to do this thanks to the list of responsibilities from before. Another feature is after every successful run of our application, we are extracting set of data to the Power BI dashboards. The main reason is that GIMI can measure and analyze data quality through the time. It also helps with detecting big anomalies between tables and dimensions. In this example, you can see that in the table in the middle, number of errors exceeded 13%, and the errors are the red ones.
Okay, and I hear you ask, what is the current status of our project? Well, we have everything tested. Everything runs smoothly, and even Jimmy himself has approved our project and our application. And Jimmy is willing to deploy the application soon into his workflow and the workflow of his department. And after we receive a positive feedback, which we are surely do, we can offer our application thanks to the easy modification to other departments as well. And to sum it up, we are team number 4, and we are helping generally to achieve higher data quality in thanks to the tracker of inconsistencies in the data. Thank you for your attention.
Excellent. Thank you very much. Time for questions. I'm wondering about the questions about such an infrastructural project.
Thank you. My question would be, you showed us kind of a prototype, how it looks like. There was a yellow, red, and orange color, mostly kind of everywhere. So does it mean that if one element is wrong, that we have to point it out 3 times that it is wrong? Or I really didn't understand. I did get the part when you said that it shows like 5 times more or something else. But why is it that if one mistake is made, and then you have to multiply or show on multiple occasions that it is actually wrong?
Well, basically in the table that we were showing, every row represents one contract. I can rewind that, I think. Okay, so here you can see the actual contracts, and every column is one variable, and the set of conditions or benchmarks given by Jimmy is usually, or a big part of these conditions are for the whole columns. Like if the sum of the columns changed by, let's say, 0.1%, it means that something is probably a little bit off, and based on the values, Jimmy can go and track these errors.
And because errors are created in the data warehouse, they are not random, they are most like systematic error, and this is because the whole columns are mostly error.
Well, basically, if a whole column is in some of these colors, it basically means that probably the whole variable was calculated wrongly.
For every single contract we had.
Yeah.
But these are only the contracts. These are not all contracts. Only with the error value. It's
yeah.
So this is
it's filtered for only the errors.
Taken out of context. Out of how many?
Let's say this table contained 700,000 records, and if there were 13%, That's 13% from that.
Okay, thank you.
Thank you very much. My question is, because I'm dealing with the plus minus the same case in my research, you have set up the conditions manually, so it means, but there are usually the things which you cannot expect. So what would you do in this case?
Well, that's the case. We are just pointing out where the errors might be, and Jimmy, since he knows the data and knows what's behind the closed door, he might know that yes, this is pointed out like it's a mistake, but actually it probably will be correct, and that's for Jimmy to decide. We are just saving time for Jimmy so that he doesn't have to track the errors himself, and we are pointing out where the errors might be.
Excellent. Thank you very much. Any more questions? If not, thank you very much.